My presentation is called Two-Sided Time, Beyond Time as One-Way Flow. First, what do I mean by time as one-way flow? Time as one-way flow can be represented by a passage of arrows, as shown here. The one-way flow of time looks like frames of film that, when projected on a screen, while the frames are permitted to move from one frame to the next, shows a motion picture. The one-way flow can be represented by transitions coming as a before and an after, by a flow of determinism showing cause and effect, a deductive flow of entailments depicting a logical chain, or following instructions of a blueprint to build a machine, etc. The one-way flow can be described as a set of two-way interactions involving the before and the after. The subject of information exchange can be taken up by the study of semiotics. Semiotics is a branch of philosophy, more focused than something like linguistics. Ferdinand Saussure developed a very simple semiotic model involving the signifier and the signified. This is basically a dyadic model involving two-way interactions because of the arbitrary relationship between the signifier and the signified. And therefore, Saussure's semiotics parallels the idea of a one-way flow. Charles Sanders Peirce developed his own semiotic model involving a triadic model, or a three-way interaction model, with the representamen, the interpretant, and the object. The representamen is more like Saussure's signifier, and the interpretant is more like Saussure's signified, but it's much less arbitrary because you have this object which is now inside the mind, and it's a three-way interaction. And it perhaps but does a better job mirroring time as something two-sided. Two-sided time is characterized by a feed-forward mode and a feed-backward mode, as shown by this diagram. The feed-forward mode resembles a one-way flow, whereas the feed-backward mode resembles a return back to the past, or what I call a self-referral. Now, it is interesting. We can define an observer as an agent that looks. We need both an agent and a capacity to look. To look is always going to require a looking back into the past. So we have a tautology, which is something self-evident and true. That is, self-referral is a necessary condition for both self, or the observer, and reality. So this two-sided time is probably, it's a property of reality proper. And the reason that reality must also have this property is that because self is also part of this reality. And self will describe this reality. And so it must be that reality underwrites this capacity for self-referral, this two-sided time. To the extent that self can present an intelligent and detailed description of reality, including the nature of time itself, this capacity must go very deep. We have a tautology that two-sided time is like photographic prints that are produced in forward time from negative film that's stored in the past. Note there is a middle term here because prints don't come automatically from out of the negatives. No, we send the negatives to a photographic studio, and the studio makes the prints. So the studio is acting as a middle term in this example. More will be said about the middle term in a moment. Now something must be said about the present moment. If we draw a transcript on the right edge of two-sided time as shown here, we can think of the present moment being located there, where the arrows stop on the right side of the diagram. And we can take a cross section of that now, turn it up, everything on its edge, and look at it. We have the black area and the white area in the cross section. The white area represents forward flow, and the black area represents the backward referral. Now, this can be regarded as a critical point, separating order and chaos. And the white area would be the order, and the black area would be the chaos. Now, I like to think of this as the particle wave duality, because the particle part would be the white area, which represents a form of determinism, and the black area would be the wave-like property, which is actually, in my interpretation or in my model, that's an echo coming up from the two-sided time in the present moment. This also represents Kaufman's posed realm, and Kaufman relates the posed realm to a warm body quantum mechanics. To the extent that two-sided time has a middle term that connects both the feed forward and feed backward modes, we have what is called Trinitarian logic. Now, the best example of this logic is Hegel's logic, which is said to have no beginning prepositions. Hegel's logic is declared to be in itself, that is objectively formulated, and for itself, that is subjectively motivated, which is a characteristic of his logic in order to maintain consistency of itself. A second example is Douglas Hofstadter's strange loop. Now, Hofstadter is one of the originators of the field of artificial intelligence. And technically speaking, he is not quite a Trinitarian because he does not explicitly state a middle term. He is more of a formalist trying to define artificial intelligence by formal methods, which does not have a middle term. So not quite, but he does have this capacity of self-referral in his strange loop idea, which is definitely Trinitarian and is taken as a given. A third example is Christopher Langen's metaphysics. He's a very interesting person. If you do a web search, you can learn about him. His metaphysics is also said not to have a beginning assumption. And that's characteristic of the tautology that we start with, that there's a self and a reality that's real that has this capacity for a self-referral, which is treated as a given. So where do we find two-sided time in physics? Well, as it turns out, our work is almost complete because all we have to do is look for symmetry conditions. So as symmetries break, they naturally break into one side versus another side, and it's always going to be with respect to time. So we have, for example, unified field theory, where the action principles are known to be symmetric under charge, parity time, or CPT inversion. And in fact, already in the literature, if you check, Boyle, Finn, Turok, in a 2018 paper, The CPT Symmetric Universe, they describe a two-sided universe, if not a two-sided time universe. And so the CPT inverted side of the universe is on the other side of the Big Bang in their model. And so you might wonder, where's the middle term in their model? I'm not sure they considered a middle term. Or where is the ether that joins the sides of the CPT symmetric universe? I'm saying you have to consider that middle term. But in fact, they already have a model of the universe, or cosmology, which involves two sides. So the unified field theory already includes special relativity. What about general relativity? Is there any conflicts there with this symmetric world? Well, general relativity is time symmetric, and it's probably also okay with CPT symmetry. So you're not going to have any problems there. So the only place where this model of reality may have a problem is with the asymmetrical second law of thermodynamics. The second law of thermodynamics. Okay, this is a law where entropy is found to increase with time flow. And that entropy is a measure of information associated with energy. And energy is always noted to run downhill, and never has it been observed to flow in the reverse direction of, say, energy rolling uphill. A ball, for example, rolling downhill, then it never has been reversed to roll back up to the top of the hill again. That would be a violation of the second law. But that's just the blunt fact of the second law. The law itself can be deduced by statistical mechanics based on free bodies that exist and interact in a closed ensemble, which is a very arbitrary set of definitions. So that's just a blunt deduction of behavior of free bodies. This interpretation, however, equivocates the meaning of representation and recognition. Now, from the point of view of Trinitarian logic, information is always represented by the synthesis of content with context. So it's a three-way interaction again, a triad, whereas entropy is only a measure of information. And so there's an equivocation of the statistical representation of the second law versus the fact that space recognizes order and dissipates waste heat. And you can read about that in my 2007 and 2008 book, Trinity. The second law, by this definition from statistical mechanics, also begs a low entropy birth of the universe. That is, the universe said to have come into existence with a very low entropy in order to justify what we see today, which is a relatively low entropy, but not as disordered as it could be. Or if the universe began in equilibrium, then it would have to be that entropy was higher at some time in the past than it is today, which would be a contradiction of the second law. And you can read about those observations in Price's book, Times, Arrow, and Archimedes' Point, or in David Albert's book, Time and Chance. So when it's all said and done, the second law, beyond the fact that it's a blunt reality that entropy increases with time, it isn't really well explained, and therefore it doesn't really fit reality. So there's a problem right off the bat with the second law. This brings up the topic of William James Sidis. William Sidis was a very unusual person, considered by some to be the smartest man in the world. And he had a tragic life as well. Anyway, he takes up the issue of the second law or thermodynamics in his 1925 book, The Animate and the Inanimate. What he deduced, first he noticed all the paradoxes we previously noted. And from those he deduced that the second law can actually run in reverse in some pockets of the universe. Moreover, he found that the second law was actually a psychological law, a law that's required to help the reality look reasonable from the point of view of cause and effect. And when you think about it, this is the perfect solution, because now we can have the CP symmetric universe with two sides. One side, the second law is found to flow to a high entropy direction, the normal direction, where entropy increases with time, and the other side, where entropy goes in the opposite direction. The entropy decreases as time flows in reverse. So we seem to have the perfect solution here. And so the idea is, are we done now? We seem to have an ontology that permits a two-sided time, and I'm going to argue that we're not really done, even though two-sided time apparently is consistent with everything we know about physics. So we're not done because we've got to look closer at gravity and see how gravity relates to this model. Because, the gravity is not unified with the other forces of nature already. So we want to look closer at that. And also we want to see, when we fit this model to what we know about, physics and biology and consciousness studies and other things, what kind of, conflicts do we come up with? And more importantly, what kind of predictions can we make so we can put this theory to the test? Now it's good to formulate our model of two-sided time in terms of the particle-wave duality. That is, we seek now to derive a shorthand notation to represent two-sided time. So let P signify all the particles in the universe, and let P inverse be the CPT inversion of P. Now, the world of particles, that is the world of P, or P, is an artificial world. We can think of it as particles all the way up, particles all the way down. It more or less represents classical dynamics like a world of billiard balls or warring egos. Now we can think of what the direction of science has in fact taken the idea of particles to extreme. We have chemicals. We have elements that make up chemicals, and we have the subatomic particles, and down to the standard model of particle physics, getting finer and finer divisions. And in the other direction, it's the same way. We go to particles, we go to organisms, we go to communities, we have planets, we have the solar system, we have galaxies. We have galaxies nested inside of the universe. And so we have particles up and down. And this is artificial, but this is the way we're going to formulate our model, which is basically the P inverse, that is the CPT inversion of P, joined by a middle term to P. And so the particle in the particle wave duality is simply given by P. And the wave now is conveniently defined as the resonance of P, given as the P inverse, echoing back in the present moment as a possibility wave, which is something now beyond classical mechanics. And this is now more realistic. We've recovered the particle wave duality. Now, also of this formulation, we note that the middle term can be represented with a deeper layer of brackets, where M signifies the deeper most inner middle term. And so this is kind of like the middle term has peelings like an onion that you can peel off one at a time and get deeper and deeper into the core of the middle term. Now let's look at gravity. First, note our model again, just for easy reference. P inverse is joined with a middle term to P. Now gravity must have been there at the beginning of time, because you need gravity in order to experience time. And it must relate to all the particles that are given mass. So you must have particles with mass. With P being drawn forward in time, and P inverse being drawn backward in time, we note that the echo returning as a possibility wave warps space-time, just as it would with general relativity. But now this model applies to quantum mechanics as well. We note that the gravitons don't actually need to exist. Gravity is space-time context only. So it has no need of a particle. So it's, one of the inside middle terms that does not actually involve the formation of a particle. Now I can speculate about the period called cosmic inflation, but bear in mind I'm not trained in physics or cosmology, so this is just speculation. And given our model again of P inverse joined to P by a middle term, and where the middle term can be represented by brackets of deeper layers, we can think of cosmic inflation starting with time and gravity, with the simplest version of a middle term, where M is just bracketed by one set of brackets. And then the strong force emerges, and now we have this representation here of two sets of brackets involving M, the middle term. And then when a weak force emerges, we have more complexification involving a middle term, but now with three sets of brackets. And when the electromagnetic force emerges, we now have four sets of brackets. Again, that doesn't have to be exactly four, but you get the idea. Because of the parity condition, which is handedness, we ended up with 3D space during this period of cosmic inflation. Whether that emerged one dimension at a time, well, that's, again, speculation. But the implication is that space comes out of time, that is, space comes out of two-sided time during the period of cosmic inflation. And so time, in this sense, is more fundamental than space. Likewise, in special relativity, we note the idea of proper time. And proper time is a duration. And so even though proper time involves a calculation involving space, the invariant comes out is a time, is a duration. It's not a distance. So again, the hint there is that time is more fundamental than space. Now, because I'm not trained in physics, I can't say too much about the standard model of particle physics. Nevertheless, I can ask questions, and these are kind of questions that I'm wondering about. One is, are there any simplifications by seeing time as two-sided that impacts on the standard model? Are there any problems that occur? And how do we treat the Higgs field? Remember, the Higgs field assigns mass to particles. The Higgs boson is itself a particle. So I would take it that the Higgs field represents one of these brackets up here in my formulation involving the middle term. Gravitons in my model don't actually need to exist. All you need is a possibility wave as context. And the standard model predicts gravitons, but no one has actually been able to measure gravitons, so we don't really know that they exist. And one thing I'm wondering about is spatial dimensions. How many spatial dimensions are needed to measure all the different interactions that are measured when you're measuring things in particle accelerators? Because, we had these three dimensions that we assumed emerged during a period of cosmic inflation. They emerge one dimension at a time, depending on what can be measured, in a theoretical sense, because you can't actually measure it. So, what's the connection between spatial dimensions and the measurement that are used, or the measurements that are made during particle acceleration, and also the formulation of gravity that I'm using? Is it agreeable to the standard model, or is it disagreeable? Are there any conflicts with the formulation of the particle wave duality that I describe, or not? Now, one area where two-sided time might have a major impact is with this idea called the holographic principle. Now, this principle, the holographic principle, was developed by studying black hole dynamics. Now, in this study, mass is proportional to entropy. And that already creates a problem because entropy is understood to relate to information. And we note that the Trinitarian definition of information is content held in synthesis with context. And it's not just a measure like, mass, for example, or an amount, or a sample space. Now, Hawking described mass of a black hole as proportional to the black hole surface area, that is, the surface area of the event horizon of the black hole, and this gave itself over to the idea that spatial information, that's information in 3D space, can be mapped onto a surface. That surface could be the event horizon of a black hole. In other words, the mass of the black hole is proportional to the surface area. Again, we're conflating information with mass, forgetting the Trinitarian definition of information. Or it could also be the spatial information in the universe being mapped onto the surface, the boundary of the universe. The same idea. And people have extended it that way as well. Leonard Susskind, for example, has done that. When you look at the field equations for the black hole, the Schwarzschild equations, the equations imply actually an anti-world where time runs in reverse beyond the black hole. So in fact, we're getting something like a CPT inversion with the field equations already, where time runs in reverse on the other side of the black hole, again agreeing with the Trinitarian definition of information. So I'm thinking that two-sided time might actually do a better job describing the holographic principle when you consider, for example, that remembering is like time travel into the past. And so if there's an ether or a middle term that allows you to connect to the past, then you should be able to remember the information that was stored in the past, which is a version of the holographic principle. I like to end my presentation by providing some references and a bibliography for future research. This presentation was a companion to my Vixra paper, The Placement of Two-Sided Time in Physics. And that paper with the rest of my Vixra papers can be found at this link shown here. If you're interested in two-sided time and its relationship to warm-body quantum mechanics, to panpsychism, to epigenetics, see my Vixra paper, Time, Life, and the Emotive Source. If you're interested in the relationship between two-sided time and Rupert Sheldrake's theory of morphic resonance, see my Vixra paper, A Possible Holarchy Representing Morphic Resonance on One Side of the Pose Realm. Also, check out the references in all three of those papers, because I'll have citations there which are not been presented in this presentation. Pay particular attention to some Vadi et al., Quantum Biology on the Edge of Quantum Chaos. That's a very good paper. And Kaufman's paper, Beyond the Stalemate, Conscious Mind, Body, Quantum Mechanics, Free Will, Possible Panpsychism, Possible Interpretation of the Quantum Enigma. And last but not least, if you are interested in Trinitarian philosophy or my understanding of the Trinitarian philosophy from 2007, please check out my book. Thank you very much.